Thank you very much. It's a great pleasure indeed being here. Merci. I'm really happy to be here. It's an honor indeed to be in this place, and I'm really grateful for Edward for this invitation. I am not going to start by advertising the University of Giessen. It was not in my plans, as Jan did. I only would like to say that we are in a building, in an old castle from the 15th century, and I hope that Jörg Lauterbach in this afternoon will show a picture of this old castle where the Institute of Geography is located in Giessen. So I will take this really demanding and challenging effort to talk about how climate would impact societies that do not longer exist, and how do they affect their resilience. And I will try to bring all types of information, all different kinds of information available into the play, and I'm going to give you a case study, the medieval Byzantium. As you see, there's a pile of books. We do have to go into books, not only for old observations, but also to look into history and the information that is available for us from the literary, the textual data. Here, down there, you see the people who are in the same group. We've been working with them the last 5 to 7 years, and I would only like to say that they are people, they are paleoclimatologists, they are modelers, people working with speleothems, there are historians, statisticians, people who are going to the field and collecting data, and people who are working directly with archaeology and history. So when we started working in this field, we had to take into consideration different issues, and one of them was consilience. Consilience, where we wanted to bring together different disciplines, and that would be how can we make it in such a way that these very different disciplines, how historians, archaeologists, anthropologists can really communicate and effectively communicate with natural scientists, considering all differences that are characterizing the disciplines and the experts in these. So we took the consilience of Wilson from his book from 1988, if I'm not mistaken, The Unity of Knowledge, where the idea is that human knowledge is a unity. And this means that when we have one and the same problem, the one and the same scientific question, then disciplines who are working on the same theme can work together and can provide answers, yes, from a very different perspective, but can contribute to this one unity of knowledge. And then we hope that the one discipline can fill the gaps in our understanding of a phenomenon that is also a part of the question of the anthropologists or the historians, and cannot really find this question and the other way around. So, what we did look into this consilience. How can we make this real? How can we bring together theoretical, methodological, and practical issues indeed that are characterizing these disciplines, and these disciplines have to come into the collaboration stage. And we looked into different questions, different issues. First of all, the methodologies that we are using. Of course, one can consider, a historian and a geomorphologist and a paleoclimatologist. They do use very, very different methodologies. And we do use different ways of producing our stories, these narratives we are using in order to understand the climate of the past and their impacts. And we do have issues with respect to our communication and the data we are using. How and where can we find the data, and how can we make best use of those. We did have some ideas on how can we, at first instance, help each other. And I will show you what it means to go towards a common research agenda when bridging these different disciplines together. So, methodologies are different. We are, of course, all working with an object that does no longer exist. It's not anymore there. We cannot go into the field and cannot really find the answer. We cannot monitor the climate of that times. And there is no more the society that the anthropologists or the historians are studying. It's no more there. So what we have to do, we have to look for traces. Traces of the past climate, traces of the societies. And this is indeed absolutely necessary. And when we are using and studying these traces, we have to use hermeneutics. And this hermeneutics, the way indeed of recognizing and trying to interpret what the traces are talking about, is grounded in different studies. Can be literary studies, can also be pottery research, or can be geochemistry or any other method that is relevant to the remains of the past that we are studying. So, let us have a look at the region. Here, you can recognize we are the northern eastern Mediterranean. This is the area that the medieval Byzantium was covering, shrinked, of course, after the collapse of the Roman Empire and the Eastern Roman Empire. And you see here that we have different types of information. You see that we are covering, we are collecting pollen data. We have data with coin finds, information from different regions which have been subject to very detailed archaeological surveys, tree reconstructions, lake sediments, and speleothems. So this is the area we're looking at, and we have collected information as well as from the economy and the climate of the medieval Byzantium. So, I said before, looking for traces from the past. Yes, we do look for traces from the past, and this is just one example. And it's one of these away from climate examples. This is a monetary circulation in urban sites. You can see we start, this is the period 850 to 1300, the medieval climate anomaly I'm going to talk to you about in a while. And we see that we have information clustered from different areas in the area. Other types of information, settlement density from the archaeological surveys. So information on the site of numbers, if you like, and also from pottery percentages. We are, of course, located, in this case, if you know a little bit of, from the geography of the area, at the southern part of Greece. This is where most of this information is coming from. Oh, yes, what I did tell you before about this, which is a very important one, is that this monetary circulation on urban sites means that has a direct correlation with the financial situation of an area. So we are considering that the more coins are found in an area, the better is the financial situation. What is important here is that we have considered mainly the bronze coinage, meaning the very low value coins that can be used more by everybody in the very simple trade functions. And also what these coins are the coins that are lost from the people who are using them. So people who are using coins and are going to the market, if you like, and pay, and they lose them, they are coins that are going away from their pockets. They are not coins who are found collected, for example, in a building. So going back here to the settlement density from the southern part of Greece. So what we can see here is that there is a period where we have a very high density, so an expansion indeed of the settlements in the area, which are denoting a well-being of the society at that time. Other population changes, and this is coming from the northern part of Greece, as you can see from Chalkidiki, the valley of Strymon river, and the Pangaeon hills. And what we see here are relevant population numbers, so changes in these different areas, and compared to a reference, which is in this case the early 12th century population levels. Other types of information that we collect and we need these traces, and these are the proportions of cereal pollen. Cereal pollen, considering what are the anthropogenic or what are the pollen, the plants that are mainly used by people. And in this case, we are of course using cereals, as cereals have been one of the most important calorie intake for the Byzantine society. What we see here is, of course, changes, again, from different areas in the Byzantine lands, and they are, of course, standardized. So we can see the changes in time on the amount of pollens, of Syrian pollen, that is found in the area. And then we are using documentary information that originally looks like this. I think it's not as extremely sharp, the figure on that side, but these are types of information that are found written in the textual data that Byzantines have left us. So information coming from different types of documents which contain climate relevant details. A work that was done by Ioannis Telelis during his PhD in Greece, trying to collect as much as available information from Byzantine texts. And what we can do is we can take this information and try to visualize these information, these observations coming from the textual data. What you see here, these are all the 50 years, except from the last one, this is a 100-year window, where we have information about climate in the area. Of course, what you can easily identify is that we have a strong bias towards information very close to the capital, the Constantinople of the time. And of course, what people used to talk about and to write about was not the very normal conditions, but mainly extreme events, or events that influenced the harvest, or the tax income, or the well-being of the people. And again, for the traces, we go to a different type. The natural proxies, the paleoclimate proxies. So what we have used here, looking a little bit more into the detail, the marine sediment here, the M2 from northern Aegean, denoting or having a signal on the annual sea surface temperatures. Or then the tree rings, as it is covered here, that is May-June precipitation, as you can see here, this orange line. Then the cave Uzuntarla, located here, Speleothems, information about effective moisture. The Cochine cave here, the black line, located down here, a very special cave that is combining information about the snow cover and the recharge of the aquifer. Above that cave, at times of enhanced snow cover. Or then the Tesser Lake, information about winter precipitation and spring and summer. Evaporation rates here more to the east. The Xoplaki cave, this line here, if we are looking there at the southwestern coast of the Black Sea, again on effective moisture, and the very famous Nar Lake, which is providing information about winter precipitation and combining with spring and summer evaporation rates. So we're trying to bring information. You can see that there's different type of traces, different types of data do require different disciplines and expertise, which experts have to communicate and bring this information together. So, what we have to do when our methodologies are as different as we are originally thinking is we do have to make sense of these traces of the past that is requiring to put them in our stories, on our narratives. And our narratives, depending on the discipline which is preparing these narratives, are different, are very, very different. And why is that? Is because all these stories have a different framework of reference. They are starting from somewhere. First of all, considering we are speaking a totally different language. If each one of us is coming on and discussing about the own science and is bringing the own jargon, it's almost impossible for other disciplines to follow. So there is a lot of effort to be made in order to bring everything to the same, cannot be, but to a similar base. So we are trying to start from the very beginning. Start, first of all, to communicate. So these narratives, the very big differences between the three disciplines I was talking to you about. History. Historians usually do not want to talk about climate change. And climate is just one other factor, just one among the many others. Publications, which are considering climate as well, appeared very slowly in the last decades, and there is no real theoretical framework that historians do follow, and there is little interest in the general laws. When we're going to the archaeologists, there's much longer engagement with climate change and much closer, indeed, to the climate people, to environmental sciences. There is an interaction between these natural and scientific methods much more than historians do. And there is a strong change after this new archaeology since the 1970s, where there was a very big difference. And there's an interest in these general laws and theoretical frameworks. On the other side, the environmental scientists and the climate people, who are interested in the societal impact of the climate change only very recently. It is getting more and more in that direction, but it's not as much important when we're looking into the past. The current global warming is the one and the only background that we tend to take into consideration, and we do have, of course, a bias towards overestimating the impact of climate. Which are the obstacles? Internal organization, a very strong differences between the disciplines, terminologies, the way we're talking, the words we're using, how we design our projects. Usually there is no climate role taken into consideration at the beginning of the large archaeological survey projects. Publication cultures, which are worlds apart. Climate scientists rarely would go into books and go reading the full books. They are rarely going to look into historical documents. The same is happening, of course, also for the other disciplines. Historians consider very thin or very short the information that are coming into the climate papers. And let's make it clear that historians do pay a lot of attention in the language that they're using. Climate scientists do not pay much attention indeed. It has to go fast and has to, as also Jan showed, has to be very well polished. And there are a lot of preconceptions about climate research in any case. So, what we try to do, and I'm talking about many colleagues of mine and myself in a lot of work that has started some 7 years ago, and common workshops and getting together people from the different disciplines. We tried once to get rid of the jargon that we're using and trying to explain ourselves in a way that can be understood by the others. And we try to do something that we found very effective and very helpful. Try to understand what are the expectations from the one discipline to the other, what the experts would like to hear from the climate people, and they would like to discuss about the climate signal, about variability, about the length of the changes of the different periods that we are finding, environmental conditions, the reconstruction, persistence, area, periods. And then on the other side come the climate science and say, okay, you're talking about events, which are those that are important. There's no way that we're going to go through your enormous works, and we cannot really cluster and identify these events. And then we have, of course, the different social processes that we tend to forget about, as climate is our own worry. And how can we look into the databases? These big differences that we do not have yet. So trying to go to the solution, or at least to try to put the first bricks towards that direction, we came up with some ideas that we consider that can help us to go towards a common research agenda. And that would be trying to prepare a common narrative, try to be appealing to various audiences, try not to use unknown words, not because the others cannot understand or don't know there's a language issue, but because we're using our own code. And of course, a wider audience can accept a narrative that makes it a much stronger narrative. Transform the way we speak and try to aim at synergies at the very early stages of a project design. And slowly going more to our products. What are the outputs of our work in a more hybrid, a new publication structure. And then the title was talking about resilience. Just a couple of words on what I'm going to talk about when resilience is coming into the discussion. That would be resilience of a socio-cultural system. Indeed, the degree to which the political structures, the economic relationships, and the cultural habits of a system respond to the environmental stimuli, and even more important, the mechanisms through which the impact of the environmental change and the pressures are mediated to these societies. What we know is that different cultural systems do respond differently and often indicate varying degrees of socioeconomic and political flexibility or resilience, if you like. And then we go to the medieval Byzantium. All these traces that I've shown you, all these efforts trying to bridge the different disciplines together, and then we are going to have a look on how climate fluctuations were reported and what were the economic performance and societal change as a link to these climate fluctuations, or if there was any link at all. Going to one of my favorite parts of the world, the Mediterranean. Here what you see, Mediterranean climate regions around the globe. Areas around the globe very distant to each other, but they do experience all the same type of climate, mild, rainy or more humid winters, and dry, warm to hot summers. And these everywhere between 30 and 40 north and 30 and 40 south. So we're going to look here at this part. The aim, what we wanted to do, was to contribute to the identification of causal relationships between climate and socioeconomy. And in order to do that, we have tried to bring together a very detailed comparative interdisciplinary analysis that is looking at every evidence that was available on medieval climate, about the society in the Byzantium, and there we used textual, environmental, climatological, as well as climate model-based evidence. I have shown you already before what the different traces were, what the textual and the economy and the society relevant information was, and here just give you very shortly the information from the model-based evidence. So we did use two coupled model intercomparison project phase 5 Earth system models, the CCSM4 and the Max Planck Institute Earth system model. They both start in the year 850, and this is also why we do start our work in the year 850. And we also used an older one, but very helpful for us, regional climate model, the MM5, that is forced by an older but comprehensive GCM, the ECO-G. It does have, as you can see, we have information about the external forcing. So the Earth system models are forced by orbital solar changes, volcanic changes, greenhouse gas and land use. And what is also the forcing in the case of the regional climate model, changes in the orbital and solar changes and greenhouse gas forcing, but no volcanic forcing in this case, which is of course implying some differences to the output of the other models. But what is extremely important in this case is that we are looking in a very small area, and an area which is mainly prone to precipitation changes, and what this fine resolution regional climate model can provide us is a realistic representation of the topography and the coastline of that area, a highly peculiar, a very divergent topography and coastline, and with a very high horizontal and vertical resolution that is, of course, providing more information or better information on the hydrological cycle processes in which we are mainly interested in. So, the period that we're looking at, the medieval climate anomaly, and not the medieval warm period, as Jan would very much like to talk about. It is well described also in the 5th assessment report of the Intergovernmental Panel on Climate Change, and is well accepted that multi-decadal periods during the medieval climate anomaly, and here there is a different definition, 1950 to 1250, a little bit different to the one we are using, were in some regions of the world as warm in the mid-20th century, and in others as warm as in the late 20th century. However, these regional warm periods were not synchronous. It's not what we are experiencing now. Not as synchronous across regions as the warming since the mid-20th century. And why do we say medieval climate anomaly and not medieval warm period? Because it was not synchronous, and it was not only warming that was observed during that period. There were also hydrological changes, droughts, extremes in different parts of the world. This is why medieval climate anomaly and not medieval warm period. So, during this period, what was the Byzantium like? The Byzantium was, after coming out from these early medieval crises, was a stable and expanding society with a thriving economy, and on top of that, with a complex political and cultural institutions and a societal organization that was as sophisticated that was not achieved by any other pre-modern societies. As I said, the period we're talking about is covering the period after the early medieval crises until the period that followed the fall of Constantinople to the Latins in the year 1204. And we were extremely happy to have this type of information, as the Byzantines produce written and material evidence as detailed to permit the investigation of potential societal impacts of climate variability, and that for a period of prosperity from the 9th to the 12th century. And of course, we're looking into the northern regions of the Eastern Mediterranean, as I've shown you already. The Byzantine society was a pre-industrial society and dependent on agriculture, which means that any changes in climate that would affect harvest would increase the vulnerability of the society. They were mainly focused on cereal cultivation as well as vine and olive cultivation, which were indeed not as important for the calorie intake, but they were very important for the trade. They were among the most the better or the most favorable cash crops in the area, and a series of abnormal or unfavorable climatic conditions could cause, on the one side, at the beginning, problems to the people who were, to the areas who were mainly focusing on the agricultural production, and a longer period would also cause large financial issues. Of course, it is not as vulnerable as the first part about the cereal cultivation. Any changes there would mean changes also into the not only into the amount of food available, but also the amount it would cause problems in the society as well. Other than that, the weather variability was also one of the important issues when it comes to the tax income, as the tax income for the Byzantines was mainly concerned to the area, to the land that was owned by the Byzantines, and any changes would mean problems with the tax income for the country. Of course, what was happening there was that with the time, the state was becoming one of the large owners. Together with the church, the state was owing much or the largest part of the land in the area, which means that was made even more vulnerable to any changes in climate, to any changes in the climate conditions. The important crops for the Byzantines are, as we have identified from contemporary literature, cereals, wine and olive, and what we could also identify and was extremely helpful in this case was mainly using indeed the contemporary literature was the conditions during the periods that would harm the harvest, what would be very destructive for the harvest, or conditions that would ensure a good production. In most cases, hoarfrost, frost periods in the early spring, and changes in the precipitation would mean a threat for the harvest. This is the evidence that we have used. I have shown you already before, but what I would like to point here is the different characteristics of the evidence, as they can be narratives or archives from the historical part, and they can be either qualitative or quantitative. How accurate when it comes to the time, to the chronological precision, it's very different, can start from 10 to 14 years, as for example the coins that were mainly dated according to the regnal periods, or palynology with 100 and 200 years precision. So I would like then to use this type of information and talk to you, bring you one example, and that would be the periods 1100 to 1200, and mainly concentrate into southern Greece. So the 12th century in southern Greece, and I'm going to bring all type of information together and try to make a narrative about this period. So the 12th century from the economic point of view, seemed to be one of the most prosperous periods for southern Greece, with a high agricultural productivity, significant monetary exchange, as you can see here, and demographic expansion, as we can see in this graph. Indeed, it is the period during which the Byzantine Empire, having made a significant recovery after the problems that had arisen from at the second half of the 11th century, was relatively strong, also in terms of political and military power. And during that time, what our natural proxies say, or what our paleoclimate proxies say, is that we had, in most cases, generally drier conditions and high sea surface temperatures, as well as a strong June, May to September precipitation decrease, as the three rings denote here. When it comes to the output of the models, we see that two of the models that we're using do show that we have a winter dryness. Winter, in this case, is of course the wet period of the year. It's not the December to February time, so we are covering exactly the period of interest when it comes to harvest in the area. And what we can see even more here, the relatively drier period, the very end of the 12th century. The Byzantine society during that time was coming out relatively strong. As we said, it was a military and politically in a powerful society, and even if it had to deal with 1 century of rather unfavorable conditions for the main harvest, seemed to come out as a resilient society, a society that could deal with these unfavorable climatic conditions. If we look then on the other side of the Aegean, if we go into the Anatolia, we do have similar conditions when it comes from the natural proxies, and I have to remind you that many of those, or the majority of those, do cover also the Anatolia. However, what we are facing in this same period, just one sea further, is that we are in the period just right after the Turkish conquest. It's the period where these drier conditions are coming to an already weaker Byzantine society, a society that had already dealt with the defeat in 1071 at Manzikert from the Seljuk Turks and the Turkomans in the area, and had already seen a decline of the agricultural production, as you can see here, from the curve from the southwestern Anatolia, and a decline in this agricultural production that one we can see starts already before the beginning of the 12th century. And then we do have the loss of Anatolia at the end of that time, and even further going into the sack of the city of Constantinople in 1204. So we could consider that the invasion of the Seljuk Turks and Turkoman nomads, the invasion in central Anatolia in that time, brought the economic system of this part of the Byzantine society to a collapse. Of course, there are different questions, like why did the Seljuk nomads, why did the Seljuks had to move towards that part of Eastern Mediterranean? What was the force behind that? And then I would like to go a step further. We had quite a lot of information from Byzantium, a lot of textual information, and what we did, we went to 3 time intervals that were again environmentally and climatically stressed and tested by the different societies at very different cultural backgrounds. And I'm going to talk to you about a very short period, 1580 to 1610, and that would be the Ottoman crisis and the Selali rebellion. So, forcing, we were talking about volcanic forcing, there's going to be a lot more coming up. We are talking about this very short period here, and what we can see, here we have the volcanic eruption of the last 2,500 years, and everything that is coming further down, that is stippled line, is a volcanic eruption that is stronger than the Pinatubo. Pinatubo seems to be not an extremely strong eruption finally, and we are covering this period. So we are in a period where we had a cluster of not very strong, but a cluster of volcanic eruptions during the same period. And why am I bringing this? Is because we are using climate models, and we do know that volcanic eruptions that are smaller than Pinatubo, as the majority of those that were active, that took place during the period we're interested in, seem to provide or to cause dry conditions, especially in the years 2 and 3 and a bit less in the year 4 after the volcanic eruption, as we can see here from this recent paper. So, for that period and that area, we did collect hydroclimate proxies, as it was the most important information that for the period, for the area, and because we are in a drought-prone and water-stressed Eastern Mediterranean. We did use on top, we are quite late in the period, so we have much more information. This means that we have gridded multi-proxy reconstructions. So we did use temperature, precipitation, drought spatial reconstructions, and 2 Earth system models covering this larger area. And I would like to show you what we know about our information about our proxies. So we have hydroclimate evidence. We try to use everything available, and all these have some uncertainties. Uncertainties, or if you would like, characteristics. The tree rings do not show much the multidecadal fluctuations. The speleothems do show some chronological uncertainties. The Earth system models generate possible climate evolutions, but these have to be prescribed in the external forcing, and whenever there is no external forcing in that period, we are seeing what is the internal variability of the system, of the model, and the reconstructed and simulated climate do not necessarily have to agree in the timing of the different climate events. So, the Ottoman crisis and the Selali rebellion, it was one of the major crises that was triggered by multiple environmental and human stressors, that was followed by recovery in terms of population, agricultural production, political stability, and military power. What was one of the resilience, what was the source of resilience for the Ottoman Empire? The source, the big size of the empire that could indeed deal with problems in different parts of it. At the same time, this growth, the constant growth of the empire, and especially of that period, could generate vulnerabilities in household and the imperial stage scale, because we had the shrinking per capita agricultural production with the growth, the larger the empire, and we had very large urban areas and at the same time major military campaigns of the Ottomans that could generate even larger demands on resources that could indeed increase the dependence on the climate conditions and the harvest and production of the rural areas. So the Ottoman system of resource, labor, and military mobilization was indeed able to bounce back from small impacts, but the higher the systemic breakdown was in the face of the different, multiple, and large shock. So they could manage when small shocks were coming, but when there was an increase in systematic challenges, the Ottoman Empire was coming cut short in their response. So, what do we know? We do know that we had some cold and dry weather conditions, periodic cold and dry weather conditions in that period that could cause local shortage in harvest and resources. We had a major drought in the years 1591 to 96 that led to a widespread starvation even, and contributed to a large-scale episodic, indeed an epidemic that comes from the animals. And these unusually cold winters and the variability of the precipitation, as what we can see also here in our hydroclimate proxies, was continued also in the beginning of the 17th century. And this whole, the feedback was famine, violence, population displacement and disease, and could even, there were also notes about up to 50% mortality between 1580s and 1630s. And this is how this period looks like when we are looking into the spatial reconstructions, grid reconstructions. Here this is precipitation reconstruction, the standardized Palmer drought, severity index droughts, everything is, the more brown we see in both figures, the drier the conditions are, and temperature here, temperature reconstruction, that the more blue the colors, the colder the conditions. In this case, we have used a 200-year reference period that was common for all types of data that we have used. So we do see that we have colder conditions from other types of reconstructions, independent indeed reconstructions for the area, and also dry conditions and an increase in drought severity. In this case, the drought and the precipitation reconstructions are not totally independent to the proxies that we are using, as they are on the one case based totally on tree rings, and in this case we do consider tree rings as well. And the same tree rings, I would like to say. And here is how the models are bringing this Ottoman crisis. Not much of agreement. Not much of agreement when it comes to precipitation. As we can see here, this is millimeters per month. So here on the top we have the CCSM4, and down here the Max Planck Earth System model. There is not large agreement when we are looking at these pictures. And indeed there shouldn't be. It is not expected to be. But we do see a good agreement when it comes to temperature. And why is that? We do see, again, let's see the time series, this drying trend at the end of the 16th century, not really exactly at the same time as the historical sources tell us. There is some difference there. But we do see a generally cooler period for the Eastern Mediterranean from both models. In the case of the CCSM4, which show a rather, or the timing, it's better than the Max Planck model, we can use this information and go a bit further and look at the sea level pressure. So what the climate models can do is provide us information about the dynamical mechanisms behind the different events that we are observing. So having a good timing with the period that we're looking at, we could have a look also at the atmospheric circulation. So what we see is that these drier conditions and colder conditions over the Eastern Mediterranean can be connected with these positive sea level pressure anomaly, or if you would like, a more frequent anticyclonic conditions here over Western Russia. that is indeed connected with a more stable or a persistent cold northeastern flow here influencing the area, while the weather conditions possibly connected with these central Mediterranean more frequent low pressure cyclonic conditions. We do see that we have a good temporal agreement, a good agreement in the temperature evolution between the models, and we would like to give some more faith into the models, because yes, on the one side we do have a large discrepancy when it comes to the timing, but we do know that temperature evolution, it's much more related to the impact of the external forcing, as the strong volcanic eruptions or the negative trend of the solar activity as it was observed for that time. Also that post-volcanic, what we saw, the volcanic eruptions, there is an increase in the probability of a positive state of the North Atlantic Oscillation, which for the Mediterranean has different influence when it comes to the hydrology of the area, depending on which part of the Mediterranean we're looking at. So positive North Atlantic Oscillation would mean drier conditions, especially at the western part of the Mediterranean, while the more we go to the east, the more variable the influence is. And of course, the most important is that we have a very complex hydrological pattern in the Mediterranean. Then I would like to go to the conclusions. We have tried to bring together paleoclimatologists, archaeologists, historians in a twofold approach, where from the one side paleoclimatologists address the events and assess the temporal and spatial characterization of the changes, while on the other side archaeology and history discuss the complex dynamics of the Byzantine society. We made a comparative use of the paleo models together with paleoclimate reconstructions and societal evidence. We tried to bring everything that was available at that time for this specific period, and try to create knowledge on a better understanding of the drivers behind the climate system and the coupled climate society system. We do have to consider a cautious interpretation to these approaches, as we are talking about high complex systems, not only when it comes to the society, but also when it comes to the hydrology, what we're looking at, the different variables that we are assessing. Finally, climate is we have seen that is a significant contributing factor to the socioeconomic changes in the period and the areas that we looked at, and that this Byzantine socioeconomic system was vulnerable to the changes in the climate, but only in the cases when it was experiencing significant internal or external, also political or military pressures. We have used our system models. We use them cautiously, that they can provide. They are a large base of information, a large knowledge base for us, and we do get information about the mechanisms and the underlying processes that could lead to these anomalous, or to the not normal, or the dry or wet hydrological and thermal periods in the past. And finally, great challenges do remain with respect to the simulation, especially of small and mesoscale circulation patterns. These are indeed the patterns that are of great importance for the Mediterranean and the Eastern Mediterranean, and are influencing the hydrologic variability of the area. And with that, I would like to thank you very much for your attention.